So guys, yesterday we were looking at factoring. If I had something like this yesterday, suppose I had maybe 2x cubed minus, say 4x squared minus 48x right here. You guys want to remind me how we started that yesterday for factoring completely? I want to factor that completely.
Common factor.
So I'm trying to take a common factor out of each term if possible. Is there a common factor in 2x cubed, 4x squared, and 48x, kids? 2. I can take a 2 out of everything. And then how about variable-wise? What can I pull variable-wise? So you're saying I can pull a 2x from all of these, is that right?
Yes.
So I can take a 2x out of this, I can take a 2x out of this, and a 2x out of this. So I'm going to put that out front, kids. All right, if I take 2x out of 2x cubed, what does that leave me with?
2x squared.
All right, the 2's would actually do what right here, Annika?
Oh, cross out x
Yeah,
squared.
so just x squared. And that's important right here, because yesterday we said, you know what, if you get a quadratic of the form 1x squared plus bx plus c, we might be able to factor that a little bit further, so we'll kind of talk about that. How about if I take 2x out of the 4x squared here, kids?
Negative 2.
Yep. And anybody want to guess on the last one? Well, I don't say want to guess. Tell me. What are the x's going to do right here?
24x.
Okay, but what would the x's
Oh,
actually?
24.
So plus 24 or minus 24? So right in parentheses now, guys, I've got a quadratic of the form 1x squared plus bx plus c. So we talked about factoring this into a product of binomials yesterday. Can you guys think of two numbers that add up to negative 2 and then at the same time multiply to negative 24?
Negative 6 and positive 4.
I'm hearing negative 6 and positive 4. Very good. Negative 6 plus 4. What is that? Negative 6 plus 4. What's that make? Negative 2. What's negative 6 times positive 4? Okay, so Gabriel, help me. What's that going to factor into for my product of binomials then? So you would have what?
X minus 6.
Yep.
X plus 4.
Awesome. Give yourself a pat on the back, guys. Good job. So that in a nutshell is really what we covered yesterday, right? You guys agree with that? Okay. So I know I didn't get through stuff yesterday. We've got a lot more to look at factoring-wise today. We'll make sure we're kind of good with this. But I want to go on to this idea of factoring cubes. I think that this is about where we were yesterday. Is that correct, kids? We said this core concept would be kind of important or not very important.
No.
Whoa. This is going to be pretty important to follow, okay? This is a good way to help factor. Guys, if you ever see anything to the third power, this is kind of a dead giveaway that you're using one of these right here, all right? One thing that we didn't do yesterday was make a chart of cubes up here. So I want to put up a cube chart up here for you. So let's do this. Up at the very top here, let's write down a cube chart that I think can help with this, okay? I'm going to put down, I'm just going to go 1 through 8, okay, on this. Okay. And what I'm going to do is use these values to help you with cube roots, all right? So guys, if I wanted to cube 1, what's 1 times 1 times 1? 1. So I would say the cube root of 1 is 1. Okay, what's 2 to the third power? 8. Now let's finish this chart for you. Anybody know what 5 cubed is? Anybody know 6 cubed? Anybody know 7 cubed? Very good, 343. Anybody know 8 cubed?
512.
Very good. I think it is. Yeah, it is. Okay. So if I ask you this question, guys, you see something like, I don't know, you see a 216 up there, you should think that 216 is the same as 6 to what power? 6 to the third. So these are all cube roots. The thing I want to point out to you then is this. If these values here are ever negative right here, so like I have a negative 125, then its cube root would be not positive 5, but negative 5, okay? All right, so we have these rules that we started talking about yesterday. We said we want to factor these completely, and this is the rule for it. So I have a sum of two cubes. In other words, a to the third plus b to the third. That's going to equal a plus b times a squared minus a times b plus b squared. And then if you have a difference of cubes, in other words, a cubed minus b cubed, that's going to equal a minus b times a squared plus ab plus b squared. Okay? So let's see if we can't figure out this first one right here. Down here in example 2, I'm going to blow this up quickly. Down here in example 2, it says factor x cubed minus 64 completely. Now kids, I have a question. Is this a sum or difference of cubes? It's a difference because, yeah, so we know we have a difference right here. So I'm going to write, okay, so we have a difference. Okay, I think it's a good idea, kids. They use A and B up here all the time. They use A and B up here all the time. Okay, guys, how many x cubed is this really out in front? Okay, so what I would probably do is let A equal 1x. Okay, the cube root of 1 is 1, and the cube root of x cubed is just x. Anybody have a guess on what we're going to let our B value equal? Well, up here by rule it says it's a cubed minus b cubed. So what number cubed gives you?
Hey, Parson, we did this one.
Did we already?
Yeah, I didn't know if you wanted to.
Okay, let's go over it again. Why not? What number is 64, or what number cubed is 64, kids? Careful. Want to use this chart up here. Yep, 4 to the. Okay, that makes sense? Okay, so we're going to let b equal what value, kids? All right, let's let it be 4. And we're going to use this rule right up here, right? So by factoring, this is going to become a minus what, kids? Okay, so this is going to factor into 1x minus what? 4. Okay, and then times this stuff over here. Okay, so a squared. Let's see, what would a to the second be? What would 1x times 1x get you? X squared, all right. All right, and then it says plus AB right here, so plus what? What would A times B get you here, kids? Plus 4x plus what? B squared now up here, right? By this rule, plus what? Okay, we have a quadratic right here, kids, of the form 1x squared. Were we able to come up with a number, two set of numbers that added to 4 and multiplied to 16 at the same time? I don't think we came up with one yesterday, did we? Can you think of two numbers that add to 4 and multiply to 16? Well, let's see, my options are 1 and 3. 1 and 3, do they multiply to 16? How about 2 and 2? Do they multiply to 16? 3 and 1 don't work. 4 and 0 don't work. So are we going to be able to break this one down right here, kids? No. So we're done right there. Okay. All right. So let's see if we can't figure out the next one. This next one's a little bit trickier. Okay, a little bit trickier, and I'm going to help you with that. Is that okay? You guys are ready for this? All right. This is a tricky one. First of all, we need to use this idea of factoring cubes, but guys, I don't even have a cubic property up here. This is to what power? It's to the 5th, and then this is to the 2nd. So kids, I need to stop and think here. We're factoring sums or difference of perfect cubes, but we have a 5th power up there. So if you see that right there, you kind of want to revert back to what we did on the first page. Ask yourself, is there anything I can take out of the negative 16x to the fifth and the negative 250x squared. Well, let's see, 16 and 250. Do you think of a number that would go evenly into them? 2. Good job. All right. Guys, both of these signs are what kind of signs for our values up here? They're negative. So how about we take what kind of a 2 out? Let's take actually let's take a negative 2 out. Ooh, I don't want to use that pen. Let's take a negative 2 out. So let's do this. We're going to take a negative. Okay. How many x's could I take from both? Yeah, there's 2 here and there's 5 here, so I can take 2 x's from both. So we're going to take negative 2x squared from both. Okay, help me out, kids. What would negative 16 divide negative 2 get you first?
X to the third power.
Okay, but how many x to the third power?
Negative 8.
Okay, what's a negative divided by a negative going to be, kiddos?
Positive 8.
Positive 8x to the what, kids?
Third power.
Okay, you with me there? Negative 2x squared and 8x cubed make that negative 16x to the fifth. All right, hey, what's this negative 250 divided by the negative 2 that we pulled out? Plus 125. And I don't need to put anything there because it canceled. Guys, wouldn't you know it, the part in parentheses, take a look at this. Is 8 part of our perfect cube? Is 125 part of our perfect cube? So sometimes, kids, you might have to get into a situation and say, okay, I don't know how to use the cube rules right here. I might have to take something out before I can apply it. So the part in parentheses now is the part that we're going to try and break down even further because 8x cubed is a perfect cube and 125 is a perfect cube. So kids, take a look at your chart. What would I let a equal? What's the cube root of 8, kids?
2.
2. And the cube root of x cubed would be just 2x, right? And then what's the b value going to be in this?
5.
Okay. Next question is, do I have a sum or do I have a difference here in parentheses? Sum. Okay, so let's do this. Right here, here's your rule for the sum of 2 cubes, so we're going to go what plus what first? A plus b times a squared minus ab plus what? All right, so let's do this. Still out front, we have the negative 2x squared. So it's going to factor in negative 2x squared. Okay, next part then was a plus b. So what plus what, kids?
2x plus 0.5. I
Okay.
squared it, the 0.5 and the 2x.
This is part of the equal sign that the pen kind of.
Oh, where
Know what
did
I'm
the-
saying?
Where did the 2x and the 5 come from?
Okay, what's the cube root of 8 up there in your chart?
4.
Cube root.
2.
So we have to say 2 times x. If I took this to the third power, this is like my a value to the third power. 2 times 2 times 2 is at 8. X times x times x is at x to the third. Okay. Why is b 5? Because b to the third is what's out here by rule, and 5 to the third is what makes that 125. So b is 5. Make sense? Okay. All right. So, and then by rule, what's going in here next, kids? A to the what? Okay, so 4x squared. And then minus what, kids? Isn't it minus a times b by rule?
10x.
So 10x.
Plus 25.
Plus 25. And we've used that rule. There it is. There it is. Right? Cubes can be kind of tricky, but if you see cubes, where are you going? Well, Well, you're going to go to that chart right there. You're going to ask yourself sum or difference, and then you're going to have to figure out your A value and your B value, and you're on your way. But guys, before I could use the cube chart, what did we have to take out of this one first before I could use the cube rules? What do we have to take out of these two terms right here? What did we factor out with the start? Negative 2x squared. Okay, very good. Okay, that's kind of tricky. That is kind of tricky. Okay, you guys have what you need there? Any questions? All right, here we go. Factoring by grouping. I kind of like this. This is kind of fun. Okay. Sometimes you can get away with factoring by what's known as grouping here, kids. I like to call grouping like a splitting thing right here yesterday. Okay. Here's what you kind of do with this sometimes. Factoring by grouping works like this. Sometimes it'll be written in standard form. A lot of times you'll see it as a cubic function minus a squared function minus a linear function and then your constant up here. Grouping kind of works like this. Put a line right there. We're going to work with the left half and the right half of this, okay? I want to show you something that's pretty cool about this right here, how to factor these. This works out pretty slick. Guys, look at the left half first. Can you think of anything just on the left half that you could pull out of the first two terms? X squared out of each, right? So if I take x squared out of here, what's left here? Just an x. If I take x squared out of this, what's left? If I take x squared out of negative 2x squared, what's left? Well, just minus 2, right? All agree that we factored the left half okay? Take a look at the right side now. The minus 9x minus 18. Guys, typically when there's a minus sign in front of that in the first term of the second half, you want to take out something that's negative. So look at negative 9x and negative 18. Can you think of a value or a value and a variable that you can pull out of those two terms? What can I take from negative 9x and 18? Okay. And since this one out here is negative, you'd like to take a negative out. So wouldn't negative 9 go into both of these here? I'm going to take a negative 9 from this and a negative 9 from this. Now watch what happens. This is really cool. This becomes minus 9 that we're taking out. Okay, if I take a negative 9 out of negative 9x, what's left?
X.
X. What's 18 divided by negative 9? Okay. What do you notice about these two parts that are in parentheses? They're the same. And when that happens, kids, it's kind of like saying, all right, it's like I took x minus 2 times the x squared and x minus 2 times the minus 9. It's like x minus 2 got distributed to both of those terms. So this is the really important part right here. The really important part is how do I rewrite this? When you factor by grouping, it's important to understand that they're saying, we want to factor this, but these two parts in parentheses better be the what, kids? You want them to be the same. And it turns out that this worked out perfectly for us. Okay, so here's the deal. This becomes the following. This becomes x squared, this term, and this term, minus 9. Those are the two values that we factored out. Anybody have a guess what they're getting multiplied by? Well, x minus 2 would be that it, because we took x minus 2 times x squared. That's like distributing the x minus 2 to x squared, and this is like distributing x minus 2 to the negative 9. Now, the next thing you need to do is ask yourself, all right, well, this x minus 2 part, can that be broken down any further, kids? No. But we better check x squared minus 9. There's a chance that that might be broken down. Guys, you agree that x squared is the same as x to the second, and minus 9 out here is my constant. How many x are really in this problem, kids? How many x are really in that part? The x squared minus 9. Ah. How many x? Yeah, x squared minus 9 on the left, isn't that the same as x squared plus 0x minus 9? Think of two numbers that add up to 0 and multiply to negative 9 for me. Say again.
None of them do.
Yeah, there's a set. Got to multiply to a negative number, so one has to be positive and one has to be negative, right?
-3, positive.
Negative 3 and positive 3 work. Okay, this here we need to recognize is a difference of squares. Okay, this is a difference of squares. So this bottom x squared minus 9 is going to become x minus 3 times x plus 3 times x minus 2 there on our part. So this x squared minus 9 is the x minus 3 and the x plus 3. All right, can any of these terms be broken down now? X minus 3, x plus 3? No, can't be. I'll move that up there for you, Manny, so you can see that. That's kind of a toughie. All right. Yowza. You guys have it? All right. I wish that was all that there was for factoring, but not quite the case. They also want you to start looking at saying, oh, by the way, you can also factor things in quadratic form. Now, quadratic meaning what degree? If I say you have a quadratic function, what degree are we talking? Second. Oh, boy. You see the second power written up here anywhere, kids? No. All right, so what they're talking about with this right here is they're saying, you know what? Even functions can factor kind of like quadratics. And when we talk quadratics right here, we're talking about second power stuff. So what I kind of want you to think is this, kids. I want you to think about perfect squares. Ooh, I'm not able to make that up there. Is that going to fit? I want you to think about perfect squares. Like the square root of 25 is what, kids? Square root of 25 is 5. Square root of 49 is 7. Okay. Just because quadratics mean second power doesn't necessarily mean that we can't apply it to higher powers like this. And in this example right here, we're going to try to apply it to a power of what here? Well, power of 8. Okay. First of all, kids, 625. You guys have your calculator handy? Somebody get out a calculator and take the square root of 625 for me. Somebody take the square root of 625. In fact, I'll do that right now while you're getting organized here. If I punch in 625, what's the square root of 625 according to my calculator? 25. Okay, that's interesting. How about this? What's the other value in here?
256.
Square root of 256 is what? 16. Oh my gosh. Both of them are perfect what? Perfect square values, aren't they? Here's how this works, kids. Anytime you have a difference like this right here, you know, like if I said this right here, if I had the difference of x squared minus 36, this would factor into x plus 6 times x minus 6. It's the same term, they're just conjugates of each other. There's a plus and a minus sign like this. Do I have a difference right here? I do. Okay, what was the square root of 625 again, kids? Square root of 625 is what?
25.
Okay, so we're going to call this 25. Now help me out here, kids. What's the square root of x to the 8? In other words, x, well, if you had 8 x's lined up, and you wanted to say a certain number of x's times a certain number of x's, and they're the same amount of x's, make x to the 8th, you would have a set of 4 x's times another set of, well, it'd be 4 of them, wouldn't it? Think about this, kids. X to the 8th power is how many x's? X to the 8th power is how many x's? 1, 2, 3, 4, 5, 6, 7, 8 of them. Okay? Doesn't this times this make x to the 8th? Would you agree with that? How many x's are right here? So the square root of x to the 8th is really x to the what? Okay. So what we end up here, kids, with is this. 25x to the 4th. Okay, what did we say the square root of 256 was? Since this is a difference, this is just like that x squared minus 36. The terms are going to be the same. That's what we're going to have so far. Okay. Now, have I factored it? Absolutely, I've factored it. Have I factored it completely is the question. Okay. Guys, I look at 25 and 16 and I think, oh my gosh, 25 is what kind of a number again? $25 is a perfect square, something you can square root. I also look at 16 and think, oh my gosh, kids. 16 is also what? So when we think quadratics right here, is it easy to, which of these two functions right up here which of these two functions is really easy to factor? Top one or bottom one? Think differences, kids. Difference of two perfect squares. This would just be x plus 7 and what? Right? Because the x and x make x squared. The 7 and negative 7 make my minus 49. When you do the outside and the inside, like that, a positive 7x and a negative 7x cancel. So if you have the squares, perfect squares, and you have the difference part right here, we can break this one down here on the right. So we're going to break this part down right here. Nothing I can do with the left now. So we're going to call this 25x to the 4th plus 16. Whew, here we go. Can 25 be broken down as a perfect square? What's the square root of 25 in other words? 5. X to the 4th would get cut in half. The 4 would get cut in half to a what? What's the square root of 16? So we have a 5x squared plus 4 and a 5x squared minus 4. Okay? Now, as long as we're thinking quadratics, I get to this part right here and I say, all right, I couldn't break this part down because there was addition here. Can't break this part down because there's addition here. But right here, guys, I have maybe another perfect square. Is 5 a perfect square? Do you know the square root of 5 off the top of your head? No. Okay, so when you get to this point right here, you're probably what? Probably done. Okay? All right, so the same game on example 2 here. Take a look at this. 3 terms up here. I don't see perfect squares anywhere. 2's not a perfect square. 10's not a perfect square. 8's not a perfect square. But what I do know is this. There's 3 terms up there. Are there any factors that you could take out of all 3 terms right now? Well, think 2, 10, and 8 here, kids. What factor could you pull from 2, 10, and 8 right off the bat? 2. Okay, what else could I pull from them, variable-wise? X to the 5th. Yep, I can take x to the 5th. 2x to the 5th out of each. Here we go. All right, the 2 is taken out here, so that's gone. So if I take x to the 5th out of x to the 13th, what's left?
X to the 8th.
If I take 2x to the 5th out of here, what's left?
5x to the 4th.
Yep. If I take 2x to the 5th out of here, what's left?
4.
Now you look at this and you say, how in the world is that a quadratic parser? And I'm like, well, here's the deal. What do you notice about your powers up here, kids? What power do you have here? 8, 4, and then no power right here. How are 8 and 4 related to powers? 4 is how much of 8? All right. When you see this right here, if you ever see where 8 and then 4 is right here, that's a tip-off that they want you to use quadratics. And here's how this works. It's kind of the same thing. This is kind of like 1x squared out here, but it's really 1x to the what, kids? 8th power. Help me here. Can you guys think of two numbers that add to 5 and multiply to 4 at the same time? Add to 5, multiply to 4 at the same time. 1 and 4. So here's how this works. This becomes the 2x to the 5th out front. We all agree how that got out there. Watch what I do here. I'm going to call this x to the 4th and x to the 4th like this in parentheses, because if you took the x to the 4th times x to the 4th, what would that make up here, kids? Okay, now, you said 4 and 1 were my values, right? So if I put a plus 1 here and a plus 4 here, help me. What's 1 times x to the 4th? 1x to the 4th. What's 4 times x to the 4th right here when we FOIL that out? And I add them together. Isn't that 5x to the 4th right here? What's the 1 times the 4 going to get you? 4. Okay. Get to that point right there. Say, gosh, there's no x squared term in here, so I can't work with that. And there's no x squared term in here, can't work with that. So you're pretty much done. Okay, these are plus signs, so I can't work with that. That's probably it right there. Okay, Mr.
But
Sterling.
it doesn't like the plus work because doesn't that like go out to like x squared and then plus like 8x then plus 2?
Are you saying right here?
Yeah.
This one here?
Yeah.
So you want this to be x squared? I would love it. If this said minus 4 right here, Sterling, I would love this because then I could do x squared plus 2 and x squared minus 2. If that was a minus 4. That rule's only going to work if you have a, what kind of sign in here between these two terms? Yep. And a lot of factoring is going to be, I got to be honest with you, a lot of factoring is practice. Just number sense and practice with factoring is important, okay? I see what you're saying right here. I see exactly what you're saying. This could probably be broken down to find some more zeros. But here's the deal. If I graphed x to the 4th plus 4, you want to know what this graph would look like? Let me show you. X to the 4th plus 4 is going to be a graph that looks like this. Okay, is that going to come down across the x-axis anywhere again? No. So what that's telling me right there is if this part doesn't cross the x-axis anywhere, I can't factor that anymore without the idea of imaginary numbers. Okay, make sense?
Where's the x to the 4th power?
Where do you mean where's the x to the 4th power go?
From, where's it from?
Where's the x to the 4th from? No problem. So we got to this part, x to the 8th, right? That comes from this idea. If I took something times something to make x to the 8th, what two things would you multiply together that are exactly the same to make that? So this x to the 4th times x to the 4th is making this part x to the 8th there. So if I had, say, x to the 20th up there and you wanted to split that, x to the 20th would become x to the what times itself? Yep. What times itself would make x to the 20th? Well, it would be x to the 10th. Yep. Got it? Okay. Quadratics are kind of tough, all right? Okay. Let's get this last page taken care of here. Guys, there's a core concept on this last page. It's pretty sweet. Okay? Here's the deal. Factor theorem is pretty important. It says a polynomial f of x has a factor x minus k if and only if f of k equals what? 0. They want to know, kids, is x minus 3 a factor right up here? Okay? How many of you guys say, yeah, I kind of like that synthetic division thing? Kind of helps, okay? Here's the situation. Give me a factor of 32, kids. What's a factor of 32?
8.
8. Why is 8 a factor of 32, kids?
Because it multiplies to minus.
How many times does 8 go into 32?
4.
So if I took 4 times 8, I'd get 32 here. What's that make your remainder? 0. All right, let me ask this question. Is 8 a factor of 36? Because it goes in here 4 times. What's 4 times 8?
22.
What's your remainder here?
4.
So I could say something is a factor of something else if the remainder is what, kids?
0.
Okay, so what we're looking for up here is the following. In order to know if something is a factor of something in terms of polynomials right here, in other words, is x minus 3 a factor for x squared plus 6x minus 12? We need to use synthetic division to show that the remainder is what value? 0. Okay, we want to show that the remainder is 0. So in this first example that I have up here, in this first example, they say, hey, is x minus 3 a factor of x squared plus 6x minus 12? And you're like, I don't know, but I think I can show you. Let's do this synthetically, kids. What would the k value be if this is of the form x minus 3? What would the k value be to start with? It's kind of the opposite of that sign. I'll put 3 up there. Okay? How about my coefficients? And make sure you don't skip any terms in there. What's your first coefficient?
1.
1x squared
6.
plus 6x
Minus 12.
minus 12. All right, synthetic geniuses, help me.
Bring down the 1.
Bring down the 1
Times 3.
times 3,
3 plus 6.
which is,
9. Times 3.
which is,
27.
add that together.
Minus 12.
What do you get?
8.
Isn't negative 20, I'm sorry, negative 12 plus 27, 15? Is that remainder 0? Therefore, is x minus 3 a factor of x squared plus 6x minus 12? Absolutely not. Not a factor. X minus 3 is not the factor. No Maury Povich fans in here? I should say it's not a factor. Okay? Let's try the next one, kids. In fact, you guys try the next one. It wants to know whether x plus 3 is a factor of this mess right here. Quick question, what's the k value in this? Go. Matt, you know your Chromebooks over there, right, buddy? Okay. You stealing my power again? It's $6.25 per kilowatt hour. Or you can just fork over one of your World Series and give it to the Twins. Right, Rhett?
Yes.
Yes, the what?
It is a factor.
Let's write this down. What's the k value I'm going to put up here, guys? If I'm checking to see if x plus 3 is a factor, what do I throw up in here for k?
Say that.
What value do I put in for my k? Negative 3, because here's the deal. The reason it's negative 3, guys, is what value would you put in for x to make this 0? Negative 3. That's why it is the way it is. All right, kids, what am I putting in for my coefficients?
2, 10, 11, negative 1, 6.
Wow, there's a lot of them here. All right, kiddos, help me out here. I'm going to put a plus sign down here so I remember I'm adding. What am I bringing straight down first?
2,
2 times negative 3 is what, kids?
Negative 6.
Add together.
4. Negative 3 is 12. Negative 1. Times negative 3 is 3. Plus negative 1 is 2. Times negative 3 is negative 6.
Oh my gosh. What happened right here, kids?
Plus 3 is a factor of.
So x plus 3 is a factor of 2x to the fourth plus 10x to the third. So I could say in the case of 2x to the fourth plus 10x to the third plus 11x squared minus x plus 6, x plus 3, you are a factor. Because the remainder was what?
0.
Yeah. Okay, so x plus 3 is a factor. Okay, kids, so let's carry this forward. Do you understand the synthetic division? What are we looking for our remainder to be if we want to know if something's a factor for those polynomials? What do you want the remainder to be? 0. It has to be 0, okay? Has to be 0. So let's move forward here. How in the world can I take this idea of synthetic division, knowing that something might be a factor, to help us factor things a little easier than what we've looked at so far? Well, here's how this would work. It says, first of all, in example 6, show that what, kids? X minus 2 is a factor of f of x equals what? X to the fourth. And then after that, they want us to factor this thing what? Okay, they're already telling you x minus 2 is going to be part that you can factor out, right? So if I can take x minus 2 out, boy, it would sure be nice if I knew what was left over. So let's check this out synthetically first. This is so cool. Watch. Guys, what are you putting in for k? All right, here's the deal. If I take this polynomial right here, x to the fourth minus 2x cubed plus x minus 2 and divided by x minus 2, I'd really like to know what I get out here. So help me with coefficients of my polynomial or my dividend. First coefficient.
1, -2, 0.
Ah, I don't see a 0.
You have to,
Why do I put 0?
because there isn't that value.
Yeah, it went from x to the fourth, x to the third. They skipped what term, kids?
X to the second.
So we've got to say, well, there's no x to the second term, so that's why I have to put a 0 in here. Then down to my x term, which is 1, and then what's the constant term? So to show that x minus 2 is a factor, we darn well better get a remainder of what first? 0. Okay, watch this. Watch this. Help me bring down. We're going to have a 1, and then a what? A 2, a 0, 0, 0, 0, 1, 2. Oh my God, kids. What's the remainder?
0.
Okay, so now here's the situation. How do you factor this completely? Well, it's not too bad to do because at this point right here, this is saying, you know what? If this is your remainder, then this is your constant value. Okay, and then this is your x to the first term, and this is your x squared term, and this is your x to the third term. Okay? So when I took this polynomial right up here, this long x to the fourth, and divided it by x minus 2, what do we get as leftover, kids? What do we get as a leftover? We get really 1, right up here, guys, 1 what?
X to the third.
Plus a constant of what?
1.
Okay, check this out. From our synthetic division, we know that our quotient is x to the third plus 1. So what I'm going to put right here is the following. We already showed that x minus 2 was a factor, didn't we? So we know one factor is x minus what? Come on, guys. X minus what? 2. And we said when I divided that out, we came up with a quotient of x to the third plus 1. Guys, look at that, x to the third plus 1. Isn't that the sum of perfect cubes? Isn't x cubed a perfect cube? Isn't 1 a perfect cube? Oh my gosh. So from this right here, I can say A is equal to X and B is equal to 1. So by rules, I'm not going to make you look back at this. This is going to become X minus 2. This becomes X plus 1 times X squared minus 1X plus B squared, which would be 1 right there. Okay, that would be your part right here. This one part, X cubed plus 1. This is the sum of perfect cubes. I go back to that chart that says A cubed plus B cubed is equal to A plus B times A squared minus AB plus B squared. That's what you would have right there. Holy smokes. So factored form, here's looking at you. What do you guys think? Synthetic division helpful or hurtful? Helpful. So we want to make sure synthetic division is our friend, because friends help. Okay, last one right here. Good application right here. This will be something we're going to look at in terms of what zeros mean. Last one. So during the first what, kids?
Seconds of a
Roller coaster? I like roller coasters. Who wants to go on a roller coaster ride? Okay, give me some sort of sign we're alive right now. Okay. The function g of t is equal to 2t cubed minus 19t squared minus 25t plus 42 represents the what, kids? Height in feet of the roller coaster after t seconds. So if I wanted to know how high up I was on this roller coaster after 5 seconds, what would I plug in for t? Well, you plug a 5 minutes. It says, how long is a roller coaster at or below what? Ground level on the first 12 seconds. Well, kids, we always kind of think of ground level as what height? 0, okay? So you guys help me quickly. I'm going to put into decimals right here this function. Will you guys read that for me, please? What's the function there that they give us? Anybody? Whoops, hang on a second. All right, what's the function there, kids? Sterling, will you read that for me, please?
During the first 12 seconds of a roller coaster.
Well, just give me the function part that we're going to graph.
GT equals 2t
To the third, okay.
negative 19t to the second negative 25t plus 42.
Plus 42?
Yeah.
Okay, kids, and it said it wanted to know how many seconds is it at ground level or below ground level in the first 12 seconds. So I'm going to go into settings and decimals, and I think this is something you should pay attention to. It wants to know for the first 12 seconds. So on your x-axis, kids, here's what you're going to do. You're going to go ahead and put in, I might put -1 in, and I might put in 13 up here because I want to know just for the first 12 seconds. So I want to see my window for the first 12 seconds. Okay, here's my graph, kids. It looks like we're at ground level at how many seconds here? Okay, ground level would be the x-axis, and then at 10.5. So it looks like we're below ground level on this from what to what, kids? You're up above, up above, up above. But then at 1 second, you're at ground level. And then every time between 1 second and how many seconds here? Between 1 second and 10.5 seconds, you are below ground level, okay? So, what I would say on something like this, kids, whoops. Okay, put into decimals. Okay, the x-axis would be like ground level for that graph, wouldn't it? Because that's where the height of the graph is 0, so ground level, 0, okay? Our graph kind of looked like this. Came down, went back up. This happened at 1 second and at 10.5 seconds. So we consider those to be our zeros. So it says, how long is the roller coaster at or below ground level in the first 12 seconds? Well, kids, what's the difference from 1 second to 10.5 seconds? Time 1 second to 10.5 seconds. How much time can it elapse? Yeah, so how long is it below? It's below or at ground level for 9.5 seconds. Okay.